Hello and welcome back to this YouTube series about Flint. Today we are looking into the Flint format. This will be, I think, a long video, so maybe I will split it into parts, but that you will really see directly in the title. So the plan is for today we make two tests. The first test will be a connect fences 2x2. That means we create a stone platform with 4x4. Then we put placing on the middle square the fences, each fence a tick, and we assert each ticks. And then on the second test, we try to use we make a custom behavior. That means if you're using a fence, that means you're clicking with an item or without an item from our inventory on a fence, we have different behaviors. If you click with a fence, then it makes all connections. That means it will connect to the wall, to that area next to it, like it would be a fence there. And if you click on the fence without an item, we will remove all of this. I think it will be more clear later when I will show it to you. So, but to write all these tests, we need to learn what is a Flint test and what is a part of it. So we have a basic structure now. The basic structure is we have a Flint version. We have a name, we have a description, we have a tags, we have a Minecraft IDs, we have a dependencies, setup, timeline, and breakpoints. So to directly break it down, the Flint version, when it hopefully later when you're watching it, we will have Flint versions, but currently it's ignored from everyone. But the plan is to run Flint tests, older versions, if we have more and more functionality. Then we have a name of a test that should be the same name as the file name. Then we have a description. That means it should describe what this test does, because some tests have multiple hundreds of thousands of lines. So I don't want to read the thousands of lines to get what this test will do exactly. So for that, the description is there. Then we have tags. Flint native and Flint CLI can have tags. Tags are there to filter. That means you can say you want to run all tests, for example, with a tag fence. That means all Flint files, what we have written with a tag fence, will be selected and executed. This gives you the option, for example, to run all redstone tests, for example. Then we have Minecraft IDs. If you have a tracker which checks the progress of a specific block or item or entity, for example, then you can write it down into a Minecraft IDs, because we have a specific output format that outputs like which Minecraft IDs, and if it test fails or passes, so you can use it for these trackers and directly say, okay, this test is for this item, and can say, okay, for this item or for this block, 90 from 100 tests are passing, so it means it should be really accurate to a Minecraft vanilla behavior, for example. Currently dependencies are also not really implemented, which is the main idea is if you require specific functionality for your test, which is tested in another ID, another test, because when the test files will be too big, you can give it as a dependencies, and then at first this test is depending on to check, okay, is this happening or not? And because if a previous test already fails, which it depends on, then you will not run, because it doesn't make any sense. Then we have the setup, which is the main part what we define multiple things, but for example the cleanup area, what the Flint CLI needs, but for that when we're defining it. Then the timeline. Here comes the full, describes how a test works. And then we have breakpoints, which is currently used for Flint CLI. What I showed you already last video. That means you can set a breakpoint, and when the behavior and says okay, you can stop there. So coming to a setup, currently the setup has two things. It has cleanup area, like I said, from Flint CLI, which gives you need to say which region it is, and then we have a player, which about the inventory and the selected hotbar. More for the player comes later when we need to write it in the test. Then we have the timeline. The timeline, like I said, have actions per ticks and the action types. And currently one tick can have multiple action types, and one action type can be on multiple ticks. We learned a lot now about the basic structure. So we will create our first JSON file. I, for example, using now here Visual Studio, and we create our first test. We call it fence connection.json. So then we need to directly start the first thing, and we have already a schema. So this will maybe say this is unload because it's untrusted. To solve that problem, for that we need to create a folder called .vscode, Then we create var settings.json. And here we're putting this file in that says, okay, the schema download with trusted domains, we trust all of it. And here the error is gone. Perfect. Then we start with our Flint version. It says it has currently a string, so I will add 1.0 because currently, like I said, we have nothing. And we have a name, it's fence connection without the JSON. Then the description. We doing currently that, calling it test default behavior for fence, which each connection or direction will be tested. Not good, but I think for this test case it should be more than enough. Then we have our tags. We using here, for example, fence connectable wood type. I think that's only more than enough to test. Then we have our dependencies. We currently depend on nothing, so this can be empty. Then the Minecraft IDs. Then we test Minecraft under oak fence. So that means we currently you having a stone platform, but stone platform is not what we want to test at the stone block. That means we only want to test the oak fence, so we need to add it here. Then we have a setup. This is currently an object. Then we have the timeline, which we will do later after relearning all the different times, and the breakpoints what we have, and it's currently also 0. And you will see it says, okay, we have all the default things defined. So like it shows the presentation in setup, we have a cleanup and a player. Currently we only focus on the cleanup, and it says we have a region, and the region I copied here from, I already prepared it. This is a region what we're doing. This is a more than 4x4 because we want to have it one ring around it, one block, but you can also have it like only with exact structure what we have. So coming back, we have 4 action types for our timeline. We have place, place each, fill, and remove. So like you saw, all action types have with setting blocks to do what we currently mainly support. So we have place. The place means it places a block there. That means we have a position and the block and this block properties. Then we have place each. That is an array of block placements. That means a block placement is like the first place what you see. It's a position and a block. Then we have fill. This is a region and it says which block it is. And remove means it will remove a specific block. That means we can also do the same with a place, block, position, and the block is Minecraft air. That means you're placing the air on the same thing. That means it's the same thing, but the remove is a simpler syntax for you. So looking again of a test, what you want to do, we have a connected fence 2x2. We create a stone platform. It's a 4x4. Then placing on each tick a fence, assert on each tick. That's the main thing what we need to do. Currently we don't know what our assert does, so we concentrate now on the first thing is we create a stone platform. It will be a 4x4, and then we're placing a fence on the first tick, and then we're looking into what we need to assert and how to assert. So coming back to a JSON file, we're seeing here our timeline. So we create our first thing. So we have it. That means on which tick we will do. The first tick is always with 0. Please don't try what we see a negative number, because I don't know what will happen on that case. Then the first thing, we will place each. It's already here. That means if block place each, we have blocks here. And yes, I already have it here. You can copy that also, that file from GitHub, where I will make a repository. This will be now our 4x4, that means this all the 16 blocks. But what we can also do is, because this is a lot of text what you need to write. Formally with hand, it's really bad. And you think, yeah, but you taught something like fill, and that's what you're also looking here is. Here's a fill. That means you're doing a 4x4 here with Minecraft stone. That means we're placing here a stone. And that's also what we want to. And like I said, on the first tick, we want to place a fence. So we have here, like I wrote already, a place, then the position, and here is a block. A block has the ID. This needs to be fixed. This needs to be written all the time. And then you can write here each property what you have this block has and can set the correct type of it. You can also remove this here, but then the block will be placed with all the default behavior and default properties. If you want to place it in a specific thing, for example, in a specific properties it should have already, then you need to have like this here, and say, for example, here, if you want to have it connected to a north, for example, then you need to write it here true. So it means in the beginning we will put it here in false, and all further blocks we will have with a 0. We will leave it away, so we see both here. So we can save it already. Now I want to have a assert, for example, after that placing all these blocks, that these blocks are there. So we are looking to the action types what we have when we see assert here. And assert has currently is an array of block checks, and a block check is a position, and it says which block should be on this position with which property. Currently we can't have multiple blocks, but for example, if you say, for example, here this came in with a never portals, for example, because you will place it on a specific locations, and it means there will be fire. And sometimes, for example, if you see, okay, the inner space will be air, and that means on a specific location there's only fire, and you want to make it easy, you can allow fire and air, for example, for inner radius. So it means if one of them are there, then the test says it's fully functional. Then we're looking again to the tests here, and we're seeing assert on each tick. So that means we need to assert the first thing on the first tick, coming back to our JSON file. And what it will do is it will assert when it will place. That means we have here a new object, add one, like we see here, it's in the same tick, and we will do an assert. And then we have the checks, and each check is, I would recommend at first a position is, for example, here -1, 0, -3 with which block is it, what we assume. We have the ID, and that's here, for example, Minecraft stone. So that means we assert here, for example, on the first tick. That means after filling the region, we assume here on this positions should be stone. I don't want to write it more, and for example, I will write it in this way, and I copy it from my temporary file, so it will be good formatted. And for formatting, for example, Flint benchmark has its own formatter, which will format there, and which we after writing with JSON, I will format that, because if you're using the default from VS Code, it will not really looking good, and it's not really much readable here. But currently, for showing you and to writing it things down, it's more than enough. So now, after asserting our stone platform, we have that tick 1 and replacing our block here. For example, now we assert we have that stone platform. That means we not much will happen there anymore. That means from now on we will ignore it. Theoretically, I would recommend to putting it still there in the checks, because if some circumstances happens and the block, for example, if you're placing a oak fence and the block below it will be removed, then this will fail after that. So that means if you're placing blocks, it would recommend to have in the assert the full checks of all blocks will be set. So that means you say the full construction should be this way all way through. When we going now to our tick 2. With tick 2, at first we will assert, and like I said, we make it now a little bit easier. Add tick 2, do assert, again the checks, and for example we will now check if the fence what we placed here in this location will be again there. That means have it here, then is, when we have here an object with ID of Minecraft oak fence. I forgot here is I want to have beforehand that pose, so it adds here perfectly in. The position will be 1 1 -1. So now it's also happy here. And for example here I recommend putting also properties in. For properties what we have, and that's for example now south, which should be false. Then we have water locked, that should be hopefully also false. Then we have east, it's also false. Then we have north, it's also false. And we have our west, and this is also false. So for example, that will be a fully handwritten thing, and yeah, I already have it prepared. It's better formatted directly. So currently, then what we will do is placing a new fence, and like in the format which I said, we have no properties here because we say, okay, we want to have a default behavior with default properties. That means no connection, like what we enforce here will be correctly written down. And then, for example, we have also here on doing again a assert on the tick 3. That's the next tick. When we see, okay, we have our main fence here, for example, what we have before, and the new placed fence and the new tick. That means these two fences should connect with each other. And the connecting of each other will be here, using here the east is true and here the west will be true. So this is the check for that. And then I will copy now everything from it tests what I have before, and currently this does it a little bit of different. So I give now my best. It means we are placing our block, then we assert again in our next tick with all our three fences, and check here in the properties if we are connect, and you can see in here this one will be connecting to both of them. That's our south and north, that's east and west. That's looking really good. Then we will be placing our last fence, will be here, and our last assert with all of the four fences, which need to connect maximum 2 or exactly 2 times, like we can see here. So, and now this Flint test is finished. It means on tick 0 we're placing our stone platform, and then on tick 1 we check, okay, is the stone platform still there? So it means was it successful. When we doing the test 1, we're placing our first fence, then we assert if that fence is there, then we placing our second fence, assert both fences, place also third fence, check if all 3 fences are there, then placing our fourth fence, and checking if all 4 are there. So if everything is correct, then this will run fine in the Flint CLI. So then give me 1 second, I will start everything and we will run this test in the Flint CLI, which I will not show here more correctly because the setup, you can see it in a previous video how to do it. So one thing what I have, because of a settings file, you need to create a folder, and I copied the file here. so you're aware of it. It means there should be no JSON in the wrong format, where so all Flint tests should rather be in the same folder, so not like here with a VS Code, for example. So create a subfolder, so everything is fine, because if you're using recursive commands. So when we are back, you can see here we run it all, and here is our Flint test, and it failed successfully. This was not planned, but a good thing. For example, to using Flint CLI, and we're seeing here on tick5 expected east true but got east false. That means here something failed in our Flint test. And we're going here to 5 and can look into console again. It says directly also 1 0 1 minus 2, and we can look here. Yeah, you can see here, for example, my problem was I copied the wrong thing, because we have currently here all three the same position. Yeah, it's a 1 1 minus 2. It's the correct position when we're placing it here in the previous one, and we can verify that because we saw it here in the last, that this last was missing. So we're running again the tests, and we're seeing here passes, and we saw the last 4 fences placing there. So this was now about the first things, that means block placing and to assert. I think I will stop now the recording, so I will create a second part with how to use the inventory and how to use an item on a block. That's also possible with new tests. Thanks for watching, and see you again in the next Flint test video. Bye bye.